Alright guys, today we're going to look real briefly at parts of the atom, just for one tiny thing. This is not an overview of parts of the atom, we're just looking at one thing on it. And then we're going to look at isotopic notation. So what I want to look at on parts of the atom is actually the mass of each particle. So there's three particles, the electrons that orbit around the nucleus and the proton and neutrons that are in the nucleus. Now the protons and the neutrons have a mass of 1 AMU, which is atomic mass unit. So they have a mass of 1. However, electrons have a mass of 1,836 AMU. That means it would take 1,836 electrons to make one proton by mass. So electrons have a very, very tiny mass, and it's so small that it basically doesn't even matter in the total mass of the atom. So when we look at mass, we're only going to be looking at protons and neutrons. So the way atoms work is that they make up certain elements on the periodic table. And the way you can tell what element it is by the number of protons. Okay, so the protons here are in the middle. So the atomic number, which is the number of protons, tells you which element it is. So like hydrogen has 1 proton and it's element number 1. Helium has 2 protons and it's element number 2, so on and so forth. But also in the nucleus you have neutrons, which are neutral. So the number of neutrons in an atom can vary. The number of protons makes it a specific element, but it can have all sorts of different numbers of neutrons. This is called an isotope. So, for example, if you look here at this atom on the screen, we've got 3 protons. 3 protons, which is we're going to write as P positive, means this is lithium. And it's got 4 neutrons. Now, it's still lithium, but it's lithium with 4 neutrons. You could have lithium with 3 neutrons or lithium with 5 neutrons, and they would still all be lithium. These are called isotopes of lithium. So they have the same number of protons, but different numbers of neutrons. Now, something else that's important in a specific atom is its mass number. Now, a mass number is basically just the mass of the atom. But how you find that is based only on protons and neutrons, because those are the only things that have a mass big enough for us to care about. So to find the mass number, all you got to do is add the number of protons plus the number of neutrons, because those are all the heavy things inside the atom. Number of protons plus the number of neutrons gives you the mass. And that makes sense because they both have a mass of 1. So if you want the total mass, you just take total protons and total neutrons. And different isotopes have different masses because they have different numbers of neutrons. For example, our lithium atom here that we were looking at had 3 protons and 4 neutrons. So its mass number was 7. But you could have a lithium with 3 protons, because all lithiums have 3 protons, plus 5 neutrons, say. And that would give you a mass number of 8. So different isotopes have different mass numbers. And the way we represent that in chemistry is called isotopic notation. Isotopic notation. So how to write isotopic notation is you put the element's symbol right here in the middle. This is chlorine. Cl is chlorine. And down in the lower left-hand corner, here you put the atomic number, the number of protons. If you're only given the symbol, if you're only told this is chlorine, you go look on the periodic table and you see its element number 17, which means it has 17 protons, and it goes right there. Now this top number here is the mass number, which we talked about before is protons plus neutrons. Now, the mass number will have to be given to you by your teacher, or they'll have to tell you the number of neutrons to add to protons. It's not something you can determine from the periodic table. There is an average atomic mass that's found on the periodic table, but you do not use that here because it means something different. We'll talk about that in a later class. So to recap, we've got the symbol in the middle written really big. We've got the mass number on the top left, which is protons plus neutrons. And then we've got the atomic number down here in the lower left. So what we need to figure out from the isotopic notation is how many protons, neutrons, and electrons this atom has and its mass number. So since it's chlorine, it's got an atomic number of 17, and that is the number of protons. So if you're looking for protons, you always just use this bottom number right here, 17. Now neutrons is a bit trickier. So we've got mass number equals protons plus neutrons. We know the mass number is 37 because it's right there. So you got 37 equals your number of protons, which is 17. We already figured that out. Plus neutrons, which I'm going to write as N with 0 because it has 0 charge. So to figure out the number of neutrons, you do a tiny bit of algebra, subtract 17 off of each side, and you get that 20 is the number of neutrons. So you got to do a tiny bit of subtraction there. And then the mass number, we already said, is this top number, 37. And the last thing is electrons, which we haven't really talked about yet. But the rule for electrons is that unless this is an ion, which we haven't learned about yet, so it's not, unless this is an ion, electrons and protons are equal so that the atom is balanced in charge, because protons are positive and electrons are negative. And the positives and negatives have to balance, so the electrons equals the protons. And there you have it. That's all of isotopic notation. So there is some practice for you in your Google Classroom. Go ahead and get started on that.